Hello, I am Marcus and my group mates are Anne and Singy. Today, we will be presenting to you our project called Favoh. Favoh is an acronym for Forensic Analysis Video of Human. The idea of our project is to analyze CCTV footage to detect objects. In our case, we will be detecting humans. The user analyzing the CCTV footage can set some exceptions to be flagged out by the system. An example of one application for our project would be placing a CCTV in a place like the server room. For example, from 6 PM to 9 AM, there should be no one accessing the server room since it is after working hours. Therefore, if the system detects someone in the server room outside working hours, it will flag it as an exception. Another example is that from 9 AM to 6 PM, there should be a maximum of 5 people in the server room. Therefore, if the system detects that there are more people in the server room than what is being declared by the user during working hours, the system will start to crop the detected humans and export the images to a folder every 150 frames. All of the images exported will have a timestamp of when it is being cropped. This is to prevent tampering with the image files. In addition, the rate at which the image is exported can be changed to the user's preference. Subsequently, we have set up the system to create a new folder containing the images every other minute. Thus, once the system creates a new folder, the previous folder will be encrypted with a password, and the folder will be sent to the user's email account. This is to help with the preservation of data being collected, as the files would be also stored in the user's email account on top of the local storage. While the system is running, there will also be a CSV file being generated that continuously appends the number of humans and the time that they are being detected into the CSV file. The CSV file could then be used by the user interface to help interpret the data to be represented as a graph. Thus, with all this information and data being collected, the user can write an incident report to present the evidence that there was a breach being detected. We will now move on to show the demonstration of this project. The project must be downloaded through GitHub at this link to be utilized. The link will be provided in the description below. The project will be running on Anaconda. This is to prevent complication with setting up of the graphic card environment in the system, which we are going to do later. After downloading the file and storing it in the desired folder, we must change the directory to the directory where the file is being stored. To open the codes for the program, you can type in code followed by a space and then a dot into the terminal, and we will open the folder. The next thing you need to download is the weights being used, which are too big to be stored on GitHub. We have provided another link to download the weights separately. The link to download the weights will be provided in the description below too. After downloading the weights, it will need to be stored in the data folder. Next, we will need to set up the graphic card environment. We can do this by typing this command into the Anaconda terminal. After the environment is set up, we need to activate it using this command. The timing for the exception, the rate at which the video is being cropped, and the amount of humans being detected before exception flag is set can be changed at detect_video Python file at line 134 onwards. The user can also use the find command in VS Code by pressing Ctrl and F and searching for the keyword called change. This will bring him into the section where he can change the exception setup. Once done, the user can use Anaconda to launch the program by typing this line. The line of code needed to run the system can be found on line 2. If the user wishes to output the recorded footage into a video file, we can use line 4 instead. However, to prevent data consumption, we are going to opt out of the video output function. The program will take a while to launch, so please do not be alarmed while it is still loading. The loading speed is dependent on the graphic card being used, where a weaker graphic card would take a longer time to run. We will be demonstrating a total of 3 live demonstrations. The first demonstration is when the time exception is met and the maximum amount of humans allowed is 1. Therefore, when another person enters the CCTV footage, the amount of humans detected will be changed to 2. Therefore, a new folder will be created, and the system will start to crop and put a timestamp on the images being cropped. Once a new folder is created, the previous folder would be encrypted, and an email will be sent to the user's email account. The second demonstration is when the time exception is met, but the maximum amount of humans allowed is 1. This time, Rick Astley is not dancing with me in the CCTV footage. Therefore, no new folder will be created and the system will not crop any images too. Nothing will be sent to the user's email. Looking at the time, usually the email will be sent after the next minute has crossed. So here is another 20 seconds of me dancing alone. The third demonstration is when the time exception is not met, but the maximum amount of humans allowed is 1. Therefore, although me and Rick Ashley are dancing over here, but there is no images being cropped and encrypted. This is because the time exception has not been met. Looking at the email generated, we can see that it is a zip file. The user can change the destination email address by heading to line 89 of the functions.py file. Please note that the zip file can only be unzipped using programs such as 7-zip. This is because we need to enter the password to unzip the encrypted folder, and the password is provided here. After unzipping the folder, the user will be able to see the images and the timestamp on it. Moving on to the representation of data, the user can type this command into the Anaconda terminal. This will launch a GUI where he can upload the CSV file being generated by the system. Therefore, he'll be able to better visualize and save the graph being generated by the system for data representation. We hope that you have enjoyed our presentation. Thank you for watching.